Hi, this is Mr. Max. I am continuing with my series on differentiation, doing a few questions. So we have a curve that has an equation y equals a function of x. And as you can see, this implies that when you have to find dy dx or the derivative of this, you are supposed to use the quotient rule. Okay, hope I wrote that. Okay, now what is the quotient rule? Again, as I said, there are so many things. At this point, I do expect that you know how to find or how to use the quotient rule. So I'm just going to go directly to it. So you have got f prime of x is equal to, so the quotient rule says you take the denominator, okay, you multiply that by the derivative of the numerator. So the derivative of the numerator is 12x squared plus 8 minus that uh, function, the numerator, which is 4x cubed plus 8x minus 4. You want to multiply that by the derivative of the denominator, which is 2. And you're going to put all of this, over 2x minus 1 all squared. Okay, low d high minus high d low over low squared. Well, that's just something that people use when they want to remember. So it's low d high minus high d low over low. That means you take the denominator, which is the lower value, you differentiate the numerator minus the numerator differentiated with the denominator, then the denominator squared. Well, these are all things that you can use to help you remember, but at this moment, you should be pretty much comfortable with the application of the quotient rule. Now let's just clean up. The calculus is pretty much done. So we're going to have um, f prime of x is equal to, so multiplying out those brackets at the numerator, that gives us 24x cubed plus 16x minus 12x squared minus 8. Then I'm going to have a negative here. Then you have 8x cubed plus 16x minus 8. Okay, that is all these multiplications that I'm doing, and so on and so on. Right, again, all of this is over the denominator. Please do not multiply out, don't expand that denominator. There's no need for that. So if you were to clean up the numerator, you should end up eventually with 24x cubed minus 8x cubed minus 12x squared. All of this should be over that denominator squared. Well, we're not done. We can still collect those like terms on top there. So this gives me 16x cubed minus 12x squared. All of this should be over 2x minus 1 all squared. So basically, I have found the derivative. Now, there's a interesting statement in the stem. It says, find dy dx, which we did, and hence find the coordinates of the stationary point. Now, the coordinates of the stationary points, you're going to find x and y, but now stationary point is very interesting because at stationary point, you should know that at the stationary point, the derivative is equal to 0. So we are going to set our derivative equal to 0. Okay, that is going to allow us to calculate. All right, so when you take that derivative and you let it equal to 0, dy dx, when you say is dy dx is equal to, well, all of that. So basically, let me just go ahead straight and just write it in. So it's 16. Oh my goodness. Just bear with me. All right. So we do have a little issue here. Let's see if we save and cancel. Let's skip, close, and open again. As I'm doing that, you see that I'm uploading videos as I'm continuing, making this project easy for you. And as I do that, please subscribe to the channel. Find ways that you can also donate to the channel, because I've dropped my my email address yesterday in one of the videos there. So let's just quickly go back to my document, and I hope that the document, everything that we did there, is still on there. Okay, so let's just drag down and see. Hopefully nothing has disappeared. By all means, it appears that it has disappeared. Goodness gracious me. Okay, right. Hopefully you can still remember. I'm not going to redo this. We were at a point where the derivative was 16 x cubed minus 12x squared, all right? And we're going to put all of that, 2x minus 1 squared, and we're going to let it equal to 0, because I was saying stationary points, we know that dy dx is equal to 0. So we are looking for the coordinates of that. So because we're looking for the coordinates, we definitely need to use the function again in order for us to find what those coordinates would be. In order for us to substitute those x values in there, we will have to find what the corresponding y values would be. In any case, this is just a straight equation. You multiply everything by 0, gives you 0, so that's 16x cubed minus 12x squared is equal to 0. Now you take out what we refer to as a common factor, and the common factor here is 4x squared. That is going to be leaving you with 4x inside, minus 3 is equal to 0. Potentially, if you have the product of two things giving you 0, it implies that one or the other is equal to 0. Okay, let's just write that neatly. And then from here, I expect you to be able to solve this linear equation. In this particular case, x will just equal to 0, or x is going to be 3/4. Now that we have our coordinates for x, I'm just going to bring down my function again. So I think it's important that I save as I go along. So let's see if I can just take a snapshot of that. And then I'm going to bring it again over here. Okay, so this is my function. Now that I have my x values, I need to find the coordinates, because it says coordinates, remember. That means we have to substitute our x values back into the function so that we can find the corresponding values of y. So when x is 0, that is going to be 4, 0 cubed plus 8 by 0 minus 4. All of this we're going to put over, all of this we're going to put 2 by 0 minus 1. In fact, when you do so, you're going to get 4 as an answer. Okay, this is when x is equal to 0. This is what you are going to get. Right. Another one, when x is equal to 3/4 from before. So we're going to do f of 3/4 everywhere we have an x into our function. Okay, just make sure of that point, 3/4. And let's see what is it that we are going to get. So we've got 4, 3/4 over here, cubed, plus 8, 3/4 over here, take away 4. All of that should be divided by 2, 3/4 over here, take away 1. Okay, You can use a calculator if it becomes a little bit too messy. Could be a bit tricky for you. So let's just have that calculator cleared up and put it in a you know much recognizable form. So you're going to have 3/4, oopsie, and all of that should be cubed. Then you have plus is 8 by 3/4 minus 4. All of this obviously is going to be, okay, that is 2 by 3 upon 4, take away 1. Okay, 59 over 8, well, let's just leave it as like 59 over 8. Right, so our coordinates, well, I have space here, but I'm just going to write it here. Our coordinate for x and y is going to be 0, 4, okay? When x is 0, we have y 4, and the other one would be x was 3/4, remember that, 3/4, okay? Then y was 59 over 8, so x is 3/4, and the y value was 59 over 8. That's how you were supposed to refer to this question, and there are some keywords that you need to understand. Things like stationary point tells you are supposed to find the derivative, and at that derivative for the stationary point, we know that the derivative is equal to 0. Okay, right. So yeah, I'm going to continue cutting this one into bit pieces, because the next video that I'm going to upload will be just to differentiate some functions with respect to x.